Alright class, in this video I'll be doing example 2 from section 5.1. It says create a polynomial function whose degree is 4 with zeros 3, -1, and 1 with a multiplicity of 2 and passes through the point -2, 6. So this last section right here, this passes through the point -2, 6 means is f of -2 equal to 6 true. So when we do this problem, we have to make sure that the polynomial passes through the point -2, 6. So when we substitute -2 into the polynomial, the result is 6. And let's get started. So let's write out each of the zeros. And notice again, I wrote out x is equal to 1 twice because x is equal to 1 has a multiplicity of 2. The corresponding factors are as such. To create the polynomial, I'm going to multiply the 4 binomials together. All right, now this is where passes through the point -2, 6 is going to come into play. So this is where you're going to ask yourself, is f of -2 true? And I'm going to do that by substituting -2 in for x. And the result is 45. So no, f of -2 doesn't equal 6. So what are we going to do? We can't create another factor, because if we did, this polynomial will have a degree 5. So we can't create another factor that looks like x minus 3 or x plus 1 or x minus 1 or x minus 1. So what we're going to do is we're going to multiply those 4 factors by some unknown coefficient. And we can do that because if I multiply these 4 factors by some unknown coefficient a, it does not affect the number of zeros or what the zeros are. So the zeros are still going to be 3, -1, and 1. So according to the problem, if you substitute -2 in for x, that should equal 6. But we know that this product equals 45. So 45a is equal to 6, which implies that a is equal to 6/45, which equals reduced to 2/15. So the polynomial, which I'll label f of x, is 2/15 times x minus 3 times x plus 1 times x minus 1 times x minus 1. So if you were to multiply all four of those binomials together, the result would be x to the fourth minus 4x cubed plus 2x squared plus 4x minus 3. You do not have to distribute the 2/15 if you don't want to. And again, if you want to see if this is correct, you can graph f of x in decimus and see if it has the roots 3, -1, and 1, and see if it passes through the point -2, 6.